Okay, so the first thing that it asked you to do was to take something that looked like this and get it into vertex form. So the part that a lot of you guys missed was moving the constant to the other side. You can do it on the same side, and that is perfectly okay. You can add and subtract on the exact same side if you want to. I know a lot of you guys probably watch videos where you saw them do that. I'm going to go ahead and stay consistent and just move it to the other side and then move it back at the end. So I'm going to change the function notation just to a y, and then minus 17 is 3x squared minus 6x. Next step is that you have to factor out whatever's in front of the x squared value, regardless of whether it goes in nicely to the b value or not. That doesn't make a difference whatsoever. You still have to factor this value out no matter what it looks like for this one. So if you end up with a fraction here, then you get a fraction there. It is college algebra. You are going to have fractions that show up on your exam. So just keep that in mind. So we're going to factor the 3 out of both of these. Y minus 17. So I'm going to pull the 3 out. So I'm basically dividing 3 out of both of those terms. So I'm left with x squared minus 2x. And I think that's the step that a lot of people miss, is that we did not pull the 3 out of both terms. Can you put the food away, please? So we didn't pull the 3 out of both terms. So we've got x squared minus 2x and then plus what we're going to use to complete the square, right? So we want to end up with that perfect square trinomial. So now from here, we're looking at this inside part for completing the square. So I'm going to take half of the b. So b there is negative 2. We're going to divide that in half and square that term. It is always half of b squared. That's just something that you have to know. They won't tell you that. So it will always be half of b squared. That's going to create a perfect square trinomial. There is an exercise in Unit 5 where it shows you where we did the completing the square using the area models that shows you exactly why we do half of b and square it in order to complete that square there. So negative 2 over 2 is negative 1, and then when you square a negative number, you get a positive number. So negative 1 times negative 1 is just positive 1. So that's what I would add in here. Now on this side, I'm technically adding a 3 times 1. So over here, I'm going to add in a 3 times 1. Okay, so then from there, we factor over here and combine our like terms over here. So I've got y minus 14. And we're going to factor this perfect square trinomial. It will always factor to half of b. And then squared. So whatever number you used here before you squared, that's the number that should be here. So if this is negative, this should be negative. Negative 2, half of negative 2 was negative 1 squared. And then last step, you just move that 14 back over. Oh, sorry, plus 14. So that is getting into vertex form using the complete the square method. You can also use the negative b over 2a to get the h value and then plug it in and get your k value if you want to do it that way. So if you prefer that method, that is perfectly fine as well. But this right here is vertex form. Okay, so that part is done. The next thing it asked you to do was to find your focal length. So focal length, this is another one that you have to just kind of know. So our a value is equal to 1 over 4 c prime. This is not c. This is not 17. This is c prime. This is a totally different number. The focal length is the c prime. That is what we are looking for. Okay? So this right here is the c prime. That is what you're trying to solve for. A is the a value from your function. So our a value is 3. Same thing right here. This is also your a value. So 3 is equal to 1 over 4c prime, which means that 12c prime is 1, which means that c prime is 1/12. Some of you guys just forgot to actually divide it back over and just called it 12 instead of 1/12, or whatever the number was for your equation. So that is my focal length, is 1 over 12. It asks for the vertex. We really already found that. Vertex is your h and your k. Do you remember that h is always opposite sign? Because your formula is x, your ax minus h squared plus k. So whatever your h value actually is the opposite, bless you, is the opposite sign of whatever's in that set of parentheses. So here, since the x minus 1, that means my h value is actually positive 1, and then the k stays the same side. So this is my vertex, is 114. My a value is positive. So this graph looks something like this, where we're over 1 and we're up 14. So then it asks for a focal point. The focal point is always a distance of C prime over the vertex. So from my vertex, you have your focal point that sits inside the parabola. You have a directrix that sits behind the parabola. Okay, your focal point is always in the parabola, no matter which way your parabola faces. So keep that in mind. So my focal point, I'm just going to take my h and then my k plus c prime. It is always plus. So even if my c prime is negative, I'm going to add a negative value. So it will subtract. But we always do k plus c prime for the focal point. So here my k value was 14. And I need to add 1/12 to that. Okay, to add them. So you can either just do 14 and 1/12 you could have done for me. I think they convert them all to improper fractions. So just for the sake of doing that, we'll do that. So you need to have a common denominator. So I'm going to do the 14 times 12. So you get 168. So this is 168 over 12 plus 1/12, which would be 169 over 12. And it is a focal point. So the h value will stay the same because we're still lining up vertically. So the h value is exactly the same, but it goes up to 169 over 12. And you would just leave it like that. I don't remember what it asked for next, but let's go ahead and do directrix since we're here. So the directrix is the line directly below it, so that would be y equals. And for your directrix, you just take your same k value, and this time we are going to subtract c prime. So k minus the c prime. So we already have it converted, so that's 168 over 12 minus 1/12. So we've got a directrix at y is equal to 167 over 12. Okay, they're going to be ugly. It doesn't really matter. Just put down what it is. They may give you something that works out real nice, where you end up with nice little values. I think on the Canvas portion of the exam, they gave you like your a values were fractions so that your answers came out really pretty. But whatever it is, just plug it in, whatever you got there. Okay, so focal point and directrix. That was probably the most missed part on both exams, on both sections of the exam. Axis of symmetry. It is the vertical line that goes directly through the vertex. So since it's a vertical line, that means it's x equals, and then it goes through the vertex. So x equals whatever the h value is of your vertex. So x equals 1 is the axis of symmetry. It will always be the h value of your vertex if it's a vertical parabola. There are horizontal parabolas, but we haven't really done a whole lot with those. Y-intercept. All right, so for your y-intercept, you just make x equal to 0. So if I go back to the original, because to me that's the easiest, if both of those are 0, then the y-intercept is just at 17. So the y-intercept, when x is 0, y is 17. And if you just put 17, that was okay as well. When x is 0, y-intercept is the same no matter what the function looks like. If you make x 0 and just solve. So here, when x is 0, you get y is 17. But that's true of all functions. And then the last thing was the x-intercept. So for your exam, I did remove the x-intercept question because some of you guys got beautifully factorable x-intercepts, and then some of you guys got horrible quadratic formula looking thing. So I just kind of dropped it from that since most people left it blank anyways. I figured it'd work out. So the x-intercepts, right, happen when the y value is 0. So y-intercept happens when x is 0. X-intercepts always happen when y is 0. So when you're doing that, your first thing would be to look to see if this thing factors. Okay, so look to see if it factors, because if it factors, that's obviously the easiest way. 3 and 17 are both prime, and neither of those are going to make a -6, so this does not factor in any way, shape, or form. So then we would have to use quadratic formula, which we're going to do a whole lot of in Unit 6. X is equal to -b plus or minus square roots b squared 4ac all divided by 2a. You do need to know the quadratic formula. They definitely expect that you know that by the time you hit college algebra. Okay, so then you're just plugging in. So -b, so -6 would be +6. -6 squared, 4, 3, 17, all over 2 times 3. I doubt, well, no, I take that back. They will, because they're throwing in Unit 6 now. So then from here, you're just reducing, and if you get a little bit confused on the reducing of the radicals, we're going to do more of that as we go through Unit 6 this week, so don't overly concern yourself if you're a little lost, but again, it's quadratic formula. You've been doing it since 8th grade, so hopefully we can kind of do that. So 12, 4 times 3 is 12, 17 times 12. So that'd be 204. Okay, so you've got 204, so that's minus 204. So then subtracting the 36 out of that. Would be a -168. This is all still over 2 times 3 is 6. So we get 6 plus or minus the square root of -168 over 6. The -168, so 4 does go into that, and 4 is a perfect square, so I would get, so the 4 will come out as a 2, the negative will come out as an I. Again, we'll go through that a little bit more. This is why I dropped it, because this is really a Unit 6 thing, so when you break that down, that'll break down to 2I root 42, because 68 can break into 4 and 42, which is 7 and 6. That doesn't have a perfect square, but 4 does. So I can take the 2 out, the negative comes out as an I, the 42 stays in. It's all still over 6. And then, since all of my whole numbers are divisible by the same value, I can reduce the 6, 2, and 6, because they're all my whole numbers. So I would end up with x-intercepts at 3 plus or minus I root 42 over 3. And honestly, that's not how they'll write that either, but we'll get there on Thursday. Okay, but that's how you get to x-intercepts. Again, if you can factor it, make that happen. That's definitely going to be the easier way. Okay. Questions on any of that stuff before we move to the word problem? Yes?
How do you get 14 to 17?
How do we get what?
14 to 17.
Because right here, because we're completing the square, so whenever I input the 1 to complete the square right here, we're actually inputting 3. So then I input the 3 on both sides, because we have to keep it balanced. So since I added 3 here, I added 3 here. So then -17 plus 3 makes -14. Good question. Yes? Yes. No, because this is also being divided by 3. If we wanted, we could split this into 3 over 3 plus or minus I root 42 over 3, which is what they'll end up doing. And it will end up looking like this, 1/3 I root 42. But since this is being divided by 3 as well, we can't just cancel here. So we were able to reduce here because all of them could be reduced by 2. So that is allowed, but since I can't reduce this by 3 right here, I can't really do it unless I split them into 2 separate pieces. It's a very good question. We'll talk more about that as we go into Unit 6, because there'll be a lot of that stuff. Other questions on these things? Yeah, so once I have the vertex form, this is my h and my k. But you can also do it using the negative b over 2a and then plugging that into the function to create your h and your k that way, and then plug them in here. That's another way of getting into vertex form. Correct. The h will always be opposite of this sign. K will always be the same sign. Good question. Other questions there? Okay. So then let's look at all the other things that we missed. Oh, so then the word problem, a few of them, but let's start with, let me find, all right, so then there was the ones with gravity. I highly expect you'll end up with one of these. So we had something along the lines of some distance compared to time. They gave us 1/2 gt squared plus the initial velocity times the time plus the initial height is the formula they gave you, and then they gave you everything to plug in. So they gave us that gravity was negative 32 feet per second squared. They gave us some kind of velocity. So let's just say that our velocity was initial velocity of 16 feet per second, and then some initial height. We'll call that initial height 48. Sounds great. Yeah, that'll work. So those would be the starting points. Well, let me see if I can change this so that it... Let's do an initial velocity of 32. Yeah, that should work. Just so it works out nicer. Okay, so from here you're going to plug everything in, and there was some word problem as we were like jumping off of a cliff into water, or we were shooting rockets off a cliff and landing on the ground, whatever the case was. There was like 4 different ones that they had to deal with, so it just depends on what you got as far as the situation. But basically what you had is we had some starting height, and then we were jumping or being shot off of that, and then coming down and landing on the ground and or water, something to that extent. That's the general idea of all of these things that we were looking at as far as these go. It is possible that they'll shoot it off the ground instead. Keep in mind, if they shoot it off of the ground, then your initial height is just 0, right? If you shoot it off the ground. Phone. So then, draw. So then, from there, plug that stuff in. All right, t squared, 32t, plus the 48. Right, so when you're here, this is your formula. So then half of negative 32 is negative 16t squared plus 32t plus 48. Make sure when you do your exam that you actually take the time to type it out and show them that you can plug stuff in, because you might get some partial credit for that. So most of you guys didn't even do that on the exam, so you didn't even get partial credit. You just got zeros. So at least plug them in and do that part, right? And then from there, it asks for things like what was the max height, how long to get to the max height, and then how long to hit the ground or the water, depending on what you were, whether it was like a person cliff diving or whatever, right? Oops, how long? Sorry. Right, how long to hit the water or the ground or the whatever. So maximum height means that I'm looking for the vertex. Right, the vertex is your maximum height. It's always going to be your maximum height, no matter what it is. So if they tell you that's the max height, then you know that's the y value of your vertex. If you're looking for the max height, then you're looking for the y value of your vertex. So we need to do the max height. And then how long to get to the max height. Wow, I apparently just don't want to write that. how long to the max height is going to be the y or the x value of your vertex, because that's my y value is the max height, so then we're going to look for the x value that goes along with it. Okay? So then from there, we're going to take this right here and just put it into vertex form. So again, however you want to do that, whether you want to do negative b over 2a to find the vertex or put it into vertex form, I'm going to put it into vertex form using complete the square because that's what I like better. So that is what I will do. So y minus the 48, so I'm moving the 48 over. I'm going to factor the negative 16. Leave my room to do my completing the square. I'm going to take half of b and square it. Okay, whatever I add to the right, I also add to the left. So that's negative 16 times 1. Okay, I'm technically going to be subtracting it, but add a negative 16 times 1. If you're doing them on the same side, like I saw a lot of you trying to do, just remember that this is negative, so then I would add the 16 into the same side. Because if I minus it here, I have to add it here, just for those of you who like to do it all on one side. Okay, so then putting those together, so that would be what, negative 64. This factors down, right? It will always factor to half of b. And then move that back. Okay, so then from there we've got these two already, the max height and how long to the max height. So that means that my maximum height is 64. A lot of you guys put down answers that were less than the original height, so definitely can't be less. And a lot of you guys just wrote the original height, but do keep in mind that you're jumping or being shot or whatever the case may be. I'm assuming based on these numbers that would be like a rocket being shot up, right? Because otherwise somebody jumped 16 feet in the air. Probably not happening. So max height of 64 there. And then it would take 1 second to reach max height because it's your h value. All right, so your h value. So it would take 1 second to reach max height. Okay, so then the other thing that I saw a lot of people do is they took that and they said, okay, well, I reached that 1 second, so it must be 2 seconds to hit the ground. Okay, but that's not true because this point where it is directly in between them two, this is the distance from 0 to here is 1 second. But that is not directly in between the actual zeros because if I continued this parabola, the other 0 would actually be over here. So do keep that in mind because we're leaving from a cliff or whatever this is, okay, then it's not going to be directly in between the 0 and the point of the ground. It's going to be between these two zeros, but this would be at a negative value. So to find how long it takes to hit the water, from there I would need to find my zeros. So I would take, and honestly to me that it's easier to do it from the standard form. So I would set the standard form equal to 0. 1 second. Okay, so you set your standard form equal to 0. You do need to know that that's standard form, so because they're going to ask you to put things in standard form. Standard form just means ax squared plus bx plus c. So put the standard form equal to 0. And then factor that. Keep in mind that when you factor, if you can take a GCF out of everything, you should. Okay, so here I can factor out a negative 16. And I get this, and then this right here can be factored. Because negative 3 and 1 makes negative 2, and negative 3 times 1 is negative 3. So then my two options are time is equal to 3 or time is equal to negative 1. Okay, well time obviously can't be negative. That would be this value over here if we were to continue it below the cliff, right? Then it would have been over here at negative 1. So this one we don't have to worry about. So it takes 3 seconds before we hit the ground. We'll talk about it later. Okay. So then, now going through the canvas portion of it and all the things we missed on the canvas portion. So a lot of it was the focal points and the vertexes was a major part of the canvas portion that we missed. So one of them that 80% of people in this class missed was the vertex form. Hold on one second.
Teachers at this time, please submit your ADA attendance. Teachers at this time, please submit your ADA attendance. Thank you.
Okay. So we had one that looked like this. Okay, and it asked for the focal point or the directrix, depending on your exam. So when you're looking at this, this is already in vertex form. Okay, so your vertex form is, there is no x value in here, so my h value here is just 0, my a is negative 1/8, and my k value would be 3. So the vertex of this particular thing would be at 0, 3, which you need to know in order to find your focal point and your directrix, since that's going to be directly in the middle. So then we take our a value, which is negative 1/8, 1 over 4c prime. Okay, you're going to cross multiply, so we get 4c prime is equal to negative 8. And then divide by 4. So c prime is equal to negative 2. Okay, so when we go to do our focal point, you're still doing the same thing, so our h value stays the same. And then we would do 3 plus the k value, which in this case is negative. So 3 minus 2 becomes 1, so the focal point would be at 0, 1. If they asked you for the directrix, you just go the other direction, so you take your k value. And we do 3 minus the c prime, which minus a negative would be a plus, so it would be 5. So you would get y equals 5 for the directrix. Which,
how do you get minus 4 denominator on the, so if I split it in cross multiply,
right here,
yeah.
a equals 1 over 4c prime. So a is negative 1/8, so 1 over 4c prime. And then I cross multiplied, so 4c prime times 1, 8 times, or negative 8 times 1, and then I'm solving for c prime, so I divide it by 4.
Oh, okay.
Okay. Okay, so hopefully this kind of makes sense. Since this is a negative, that means this thing looks like this, which means the focal point should be below the vertex, which it is, and then the directrix should be above it, which it is. All right, so think about what your overall shape should look like, even if you don't like graph it exactly. Just know what your overall shape should look like. Since A is negative, it's upside down. So the focal point is below it, which it is, and the directrix is above it. The other thing they could potentially give you is they could give you a directrix and a focal point, and you should know that your vertex is directly between those two. That is an absolute possibility of something they could give you, is they could give you like y equals 5, and the focal point is at 0, 1. Where's the directrix? Where's the vertex? All right, so you have to know that it's directly between the focal point and the directrix. So just keep that in mind. It's one of the major concepts. Just like the other major concept is that the vertex happens directly between the two zeros. So they could give you two zeros and expect you to find that. Okay, which kind of leads to the next one, which was the, this one was one of them too. So a lot of us couldn't do the completing the square when it wasn't a pretty number. So if you're going to complete the square, just because it's not a pretty number doesn't really make a difference. It's still half of b, and square it. You just leave it like that, and you just square the top and bottom numbers. So negative 7 squared is 49, and 2 squared is 4. Okay, so just because it doesn't happen pretty doesn't mean that it doesn't happen. So you just do the same thing. That's a 4. And then graphs. They give you a graph and they ask you to write it in standard form. Okay, which is probably what they're going to do, is ask you to convert this to standard form. But start with vertex form, because you know the vertex. This is at when x is 2, y is negative 2 is your vertex. So I would start there. So y is equal to a x minus h, which is 2, and then negative 2 for the k. So I'm just taking my vertex and plugging it in for h and k. And then I'm going to take any other point and plug that in and solve for a. This is a basic concept that's going to show up in every single unit for the rest of the school year. When you want to find one of those missing components and you know a point on a graph, you just take that point, plug it in, and solve for the missing component. So here we have the point 1, 0. So y is 0, x is 1. So 2 is equal to a times negative 1 squared, which is just 1. So a equals 2. Okay, so then they wanted it in standard form. So once I can put things into vertex form, then you're just going to expand that to get to standard form. So I'm going to multiply x minus 2 times x minus 2, which is x squared, minus 4x plus 4. You need to do that off to the side. Make sure you're doing your FOIL. All right, so x squared, negative 2x, positive 4. That's where that came from. And then distribute your 2. And then combine like terms. Okay, so go to vertex form first, and then just distribute everything into standard form. Put your phone up. All right, so then, yeah. Oh, you can finish writing it down. We good? All right. So then there was all of the word problems where it was like we hit a ball, it had a max height of this and a max distance of this. So let's say we hit a ball, whatever kind of ball, it just changes the kind of ball. Let's say that we have a max height of 10 feet and max, it goes a distance 50 feet. And then it asks for stuff like how high was it after 30 feet, something like that. So you've got, we're going to start at 0, 0. We're allowed to assume that because we're allowed to put these things on a graph anywhere we want. If it has a max height of 10 feet, again, that's going to be the y value of your vertex. So we know that right here, the y value is going to be 10. And then since this is 50 feet is how far it goes, and we started it at 0, 0, then this right here is going to happen 25 feet in because it's going to be perfectly between the two zeros. That's one of the major concepts that they're looking for, is that you understand the vertex happens directly between the two zeros because it's symmetric. So that means this is going to be at 25, 10. So now I have my vertex, so it's the same thing we really just did. So I've got a vertex, so I'm going to go y is equal to a times x minus 25 squared plus 10. And then I need to know a, so I'm going to plug in either of my other 2 points. So I'll take 0, 0 because it's easy. Uh, 25 squared is 525. And then divide that over. Reducing, so 5 goes into 10 twice, so that would be negative 2 over 105. Okay, so I have an equation now that I can work with. And then once you have the equation, you can plug in any value that they want to find your other value. So minus 25 squared plus 10. So they want to know how high. So high is the height is the y value. So they want to know what is the y value when x is 30. Okay, they could have done it the other way. They could have said something like, how far is it traveled when it reaches a height of 5 feet. So you kind of have to pay attention to which variable is which and where to plug it in. Here again, we're looking for how high, so we're looking for the y value when the x value is 30. So then you just plug that in once you have your equation. So we would do 30 minus 25 squared plus 10. So y is equal to negative 2 over 105 times 5 squared plus 10. So then right, reducing 25 and 105. So 5 goes into that 5 times, goes into that 21 times. So we get negative 10 over 21 plus 220 over 21, just getting a common denominator with the 10, multiplying top and bottom by 21. So we would get 200 over 21.
Why do you call that 25 and cross out 105?
Reducing fractions. Just reducing fractions. Because this is 25 over 1, so I'm allowed to reduce here before I multiply. So that is how you do those. The discriminant was another one that didn't go over very well. So the discriminant You don't really have to learn a new formula, but you do have to know your quadratic formula. The discriminant is just the part underneath the radical on the quadratic formula, so the b squared minus 4ac. So if I have something like 2x squared plus 3x minus 4, plug into the b squared minus 4ac part, just the part underneath the radical. We don't even need the radical, so 3 squared, 4 times 2 times negative 4. Don't really even have to go further than that, but 16 times 2 is plus 32, which is 41. So the discriminant value is just 41, and then it asked you, what does that tell you? So since it's positive, that means there are 2 real solutions. Because when you think about the quadratic formula, I'm adding some real number and subtracting some real number, so I'm going to get 2 real answers. If it were, that would be the answer for this one. If it were less than 0, then you have 2 complex solutions. That means that you're going to have 2 answers that have, they're going to call them complex roots. They might call them real roots, real solutions, same thing. If it's less than 0, though, that means you're going to have a negative underneath the radical, so they're going to be 2 complex roots. And if it's equal to 0, then you have 1 real roots with a multiplicity of 2. Those are the only options for discriminants. We'll start Unit 6 tomorrow.